This video is based on the horse herd optimization algorithm. In this video, we will try to understand what is this algorithm all about, how it is working, various steps used in this algorithm, mathematical models to update horse position in the search space, different velocity vectors for the horses according to their age, and flowchart for this algorithm. In the end, best horse among all is considered as the optimal solution for this algorithm. First of all, as you can see here, horse herd optimization algorithm is introduced in 2021, and this is the nature inspired population based meta-heuristic optimization algorithm that is basically inspired by the horse herding behavior in the nature. Due to horse different behaviors, large number of controlling parameters are used in this algorithm. This is the negative point, but at the same time, this is the plus point. We can use this algorithm to solve complex high-dimensional optimization problems. This is the horse basic body structure. Horses can communicate with each other through tail swishing, foot stomping, whinnying, touch, mutual smells, grooming, and other. Horse is a social animals and they live in group, and in the group they follow the dominant leaders. And here you can see the different body parts for the horse: back, flank, forehead, shoulder, knees, and other. Horse is a prey animals and horse predators. You can see here wolf, lion, and other. Horse is highly intelligent animal among all, and they can share their emotions with other herd members. They can remember bad situations. That's why horse forgive but they never forget. So it is a very complicated for the horse trainer when they try to train a horse first time, as horse can remember the bad situations. Now you can see the horse's classification in the herd. Horse live in the herd, or you can say in the groups, and you can see the horse age is here. Horse is less than 1 year old is foal, and horse age within 1 or 2 year is yearling, and colt is the male horse is less than 4 year old. Filly is the female horse age less than 4 year old. Mare is the female horse age is greater than 4. The male horse age is greater than 4. As we know, horse live in the herd, and in the herd they have their dominant leaders, and horse follow the strongest and the experienced one, that is the older mare. Older mare lead the herd, and here the stallion role in the herd is as a herd protector. They protect the herd in the wild, and they also gather the herd members together. Here they protect the younger one and the older one. Next you can see here, as we know, horse have largest eyes among all animals, and their vision is 360-degree. Their lifespan is 25 to 30 years, and there are more than 300 breeds for horses all around the world. Horse is highly intelligent animal among all, and their brain weight is half of the human brain weight. Horse teeth you can see here for the male horse 40, and for the female horse 36. Now you can see here horse behaviors. As this algorithm is based on different horse behavior, first you can see here grazing, that is continuous eating. Here horses can eat grass 16 to 20 hours a day, and in the hierarchy they have their dominant leaders and they follow a leader in the herd. Horses are friendly and they roam. Defense mechanism is used by horses for their protection when they encounter with the predators. Now, one by one, we will try to understand the horse behaviors as they are used in this algorithm. In the horse herd optimization algorithm, horse ages are represented using delta, gamma, beta, and alpha. Delta represents the horse ages between 0 to 5. Gamma represents horse ages range between 5 to 10. Beta represents horse ages range between 10 to 15, and the alpha represent horse age greater than 15. In the horse herd optimization algorithm, horse age is determined at each iteration and a matrix is created, and in the matrix the top 10% population is considered as alpha horses and next 25% population is considered as beta horses, and next 30% population is considered as gamma horses, and the last 40% population is delta horses. Now here you can see this is the mathematical model that we can use to update horse position in the search space at each iteration. So this is the new position for the horse, and here this is the horse velocity vector, and here this is the horse older position, and here you can see we have age that represents the horse age, whether it is alpha horse, beta horse, gamma horse, or delta horse. And this is the current iteration, and M is the total number of horses in the search space, that is 1 to population size. Now we can see how we can update the horse position according to their age. For the alpha horse, you can see here, this one is for the alpha horse, that is the velocity vector for the alpha and the horse previous position. Next, for the beta horse, you can see this is the velocity vector for the beta horse, and this is the beta horse previous position. And next you can see for the gamma horse, that is the velocity vector, and this is the velocity vector for the gamma horse, and this is the horse previous position. And this is the delta horse new position, that is velocity vector for the delta horse and the previous position for the delta horse. Here we are adding the velocity in the previous position. So what we are doing here, how we can update the horse's position in the search space. So we are adding the velocity in the horse previous position. Now one by one we will try to understand the velocity vector for the horses as according to their ages, how we can update their position in the search space. Now you can see the velocity vector for alpha, beta, gamma, and delta. So here you can see, first you can see the velocity vector for the alpha horse, that is horse grazing behavior plus horse defensive behavior, and the velocity vector for the beta is the horse grazing, hierarchy, socialism, defense mechanism. And one by one we will discuss velocity vector for the horses in the upcoming slide. Now you can see horse behavior, that is grazing. Horses can graze 15 to 16 hours a day, and they can drink 5-gallon water per day. And they can eat hay, grains, fruits, vegetables, grass, and plants. The horse herd optimization algorithm, virtual horses are used, and the virtual grazing area is modeled around each horse and with coefficient G. This is the model you can see here for grazing behavior for the horses. Here this is the motion calculation for the horse, that is the motion vector, and here U, that is the upper bound, and this is the lower bound, and this is the random value that is normally distributed random value within 0 and 1, and this is the horse older position. And here horse age you can see here, and this one is for the horse ages alpha, beta, delta and gamma. And as all horses can graze in the pastures, and you can see here we have the values for upper bound, lower bound, and for coefficient G. We can use these values for accurate results. Next, horse behavior. You can see here hierarchy. As we know, horse lives in the herd and they follow the dominant leader, and they have leader as older mare, that is the alpha mare, that is the experienced one in the herd, and adult stallion is also considered as the horse leader in the wild. Horses dominate each other in the herd for food, water, and for other resources, as the dominant horse will eat and drink first, and they dominate other horses. In the horse herd optimization algorithm, herd will follow the experienced and stronger horse among all. And this is the mathematical model for this behavior. As you can see here, this is the horse best location. Here, using this, we can calculate the horse best location, that is based on the horse best location previous position. As we know, horse is a social animal and they live the social life, and they like to mix up with the other herd animals such as sheep, cattle and other. In the horse herd optimization algorithm, this is the mathematical model that we can use to update the horse position toward the average horse position in the search space. Here, this is the other horse, and you can see this is the horse previous position, and we can update this for beta and gamma horses. After that, you can see we have the imitation and the defense mechanism for the horses. Horses imitate each other. They can learn good and bad habits from the other horses, and this behavior is often seen in the younger horses. They imitate each other, and in this algorithm, you can see this is the mathematical model that we can use here to update horses position for the gamma horses, that is the age between 5 to 10-year old. And next we have the defense mechanism that is used by the horses when they encounter with the predators. As we know, horse is a prey animal, and whenever they encounter with the predator, first they try to escape. If they cannot escape, then they fight. If horse cannot escape, then they defend themselves as fight or fight response. And horse also fight with the herd members for the different resources like food and water. And this behavior, you can see here mathematically, this behavior is represented using this equation. In the horse herd optimization algorithm, this behavior is used to update the horse position away from the worst solution. It means we will move the best horse away from the worst solution in the search space. That is the escape mechanism. Now you can see the different steps that are used in this algorithm. First, we will initialize the population for the horses in the search space, where we will initialize the position for the horses in the search space randomly. After that, using Gini-Cost function, we will calculate the fitness value for the horses, and then we will check whether the current iteration is less than maximum iteration or not. After that, we will check horse age. Here, horse age classification is done. So we will calculate here alpha, beta, gamma or delta horse age. After that, according to their age, we will update the horse position, and we will calculate the velocity for the horse, and after that we will update the position in the search space, and then we will compute new solution fitness value, and we will compare the new solution with the older solutions, and we will check after that. We will check the stopping criteria. If stopping criteria is matched, then stop and display the best solution that you found in the previous iteration, else we will repeat the loop from step 2. Now you can see the velocity vectors for the alpha, beta, delta, gamma horses. As you can see, this is the model to update the horse position in the search space. But now question is how we can calculate the velocity vector for the horses. For the alpha horse, you can see this is the horse grazing plus defense mechanism. For the beta horse, this is horse grazing plus hierarchy plus socialism plus defense mechanism. For gamma horse, you can see here, this is the grazing, socialism, defense mechanism, hierarchy, imitation, roam, and for delta horse we have grazing, imitation, and roam. So one by one you can see here. So first you can see the velocity vector for beta horse. Here the horse age is beta, and for beta horse we have grazing, that is the horse grazing behavior equation. For horse hierarchy we will use this, and for socialism we will use this one, and for defense mechanism this one is used. And in the end you can see here, this is the velocity vector for the beta horse. Next you can see the velocity vector for the gamma horse, how we can calculate the velocity for the gamma horse. So this is the velocity vector for the gamma horse, that is the horse grazing tendency plus the best location, that is the hierarchy, plus the social motion and the imitation vector, escape vector, that is the defense mechanism, and roaming. So here you can see for grazing this one, for hierarchy this one, and for socialism this one, for imitation as they imitate each other this one, for defense mechanism this one, and for roaming this one. Next you can see here, this is the velocity vector for the gamma horse. So here you can see we will put all the values together and calculate the velocity for the gamma horse. Now you can see the velocity vector for the delta horse. For the delta horse, here you can see this is the horse graze tendency plus imitation vector plus roam. So here you can see the values for each behavior, and we will put all the values together in this model, and then we will calculate the velocity for the delta horse. After that you can see here, this is the flow chart for this algorithm. First we will start with algorithm parameters. We will initialize all the important parameters for this algorithm, and then we will initialize the agent's position in the search space, calculate the fitness values, and then we will determine the horse ages, and according to their age we will update the position in the search space, and then we will check the stopping criteria. If stopping criteria is matched, then display the best solution that you found in the previous iteration, and if stopping criteria is not matched, then we will repeat the loop from here. So that's all about this video. In this video we discuss different horse behavior according to their age, and we calculated the velocity vectors for the horses according to their age, and then we updated then how we can update their position in the search space. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.